Okay, so here we're asked to prove using a 2-column proof, and it gives us PQ is congruent to QR and TQ is congruent to TR. And we're asked to prove angle 1 is congruent to angle 2. So even though that I'm doing this with you, you guys should probably still write this on a sticky note to have for future reference, right? So what is the first thing we should do here?
Make sure our given is marked.
Good. We're going to mark up our picture based on our given. So PQ is congruent to PR, and QT or TQ is congruent to TR. So, knowing these parts are congruent, what does that tell us about this picture?
It's isosceles.
Yes. So we have triangle PQR is isosceles, as well as triangle TQR is isosceles. Good. Now, those triangles being isosceles, which probably that's our first step of our proof, those two triangles being isosceles tells us what? What angles?
Q and R.
Yes. Angle Q is congruent to angle R. What else? Yes, on the small triangle, angle 3 is congruent to angle 4. Beautiful. Now, there are a lot of steps to this proof, so before we lose track of what we're doing, I want to write this in our proof. So we're just going to take this in steps.
Hey, miss, can you turn on the AC?
It is on. Yeah, I know. Someone last period turned on the heat, and I didn't notice till the end, so I changed it to cool because they are insane. All right. So what do we always write first? Good. So we're going to write PQ's congruent to PR, and TQ is congruent to TR. Because why? Given.
Yeah,
You can.
have to do it below the sticky part.
Right.
That's why you take it off.
Okay. So what did we state next about our picture? Yes, we stated that PQR and triangle TQR are what? Are isosceles. Good. Isosceles triangles. Now, which of our brand new postulates and theorems do you think is our reasoning behind stating these are isosceles triangles? Yes, definition of isosceles. And then what did we say? What did we mark congruent next? Yes, we marked angle Q congruent to angle R, and also what else?
T to R and T to Q, right?
3 to 4.
Oh, I didn't see those. You already said that.
And what reasoning do you think justifies that these are congruent?
No.
Isosceles triangle theorem. Good. The definition of isosceles only deals with the side measures, okay? The isosceles triangle theorem deals with the angle measures.
Wait, what are all the isosceles? What are all the reasons for this problem?
definition of isosceles and isosceles triangle theorem. So, like I said, definition of isosceles deals with side lengths, and isosceles triangle theorem deals with the angle measures.
Oh, so that's why they P.
Yes. Okay, so now is where it steps up a notch. Does anyone have any idea how we can know that angle 1 is congruent to angle 2? Because that's what we're trying to prove, right? Angle 1 is congruent to angle 2.
Because
Since 3 and 4 are equal, and then Q and R are
that's what I was
equal,
thinking.
1 and 2 are missing.
Right. So we know 3 and 4 are the same, and Q and R are the same. And then what makes up Q? 1 and 3. And what makes up R? Okay. And then we know 3 and 4 are the same, right? So if we take them out of Q and R, what's left? 1 and 2. So we need to find a logical mathematical process for what we just said. And this is the hard part, knowing how to, we verbally know what we're saying, but the hard part is translating it to math, right? So I'm going to start trying to lead you along the right direction here. First we stated, okay, 1 and 3 make up Q. What is a math thing that we've done this year that deals with a part and a part making a whole? Ah, now are these segments?
No.
These are, so it's the angle addition postulate tells us that angle 3 and angle 1 add up to be angle Q. So that's our next step. We're going to say angle 1 plus angle 3 is equal to angle Q. And also angle 2 plus angle 4 is equal to angle R. And how do we know that's true? The which postulate?
Angle.
Yes, angle addition postulate. All right. So now it's not so much, we've done really as much as we can with this picture. Now it's kind of focusing on furthering this proof. So we know we have to eventually get to angle 1 is congruent or equal to angle 2, right? How can how can we rework these equations to eventually get them to be angle 1 is the same as angle 2? First of all, let's look at 3. What is step 3 telling us right here? What does step 3 tell us?
That angle Q and R are congruent in the 3 and 4.
Okay, so because we know Q is the same thing as R, what do I know Q and R are equal to? What did we just say they're equal to? 1 and 3 and
2 and 4.
so we know Q and R are the same, so what can we do here?
Remember the inside measure?
Right. We can now say angle 1 and angle 3 are the same exact thing as 2 and 4. Does anyone know the reason why we know that?
Q and R are congruent.
Right. So what we did was we saw Q and R were the same, and then we saw Q and R were equal to two things, and then we set those two things equal to each other. What property is that? I'll give you a hint. That's what we just did, right? We saw A and B were the same, and we saw B is equal to C, therefore A is equal to C. Oh my gosh, it's the transitive property. Remember back to that? Remember, it's either transitive or substitution. Transitive. Remember? Okay. So now we're so much closer, right? Now we at least have 1 and 2 in the same equation. Yeah, do we have 1 equal to 2 yet all by itself? Oh no. At least we have 1 and 2 in the same equation. So how can we work on getting 1 and 2 all by themselves? Oh, I know we can get it. Someone last class got it.
What was it? What are you doing?
We're trying to get 1 and 2 all by themselves. Almost. Not, okay. So I'll give you a hint. We stated step 3 for a reason, right? We stated it for a reason. So far, we've used Q is congruent to R. We have not used 3 is congruent to 4. What about 3 being the same as 4 helps us in our step 5 equation? 3 is the same as 4. How? Okay, how? What can I do? Oh, what can I substitute? What can I substitute? I know 3 is the same as 4. 3 is congruent to 4.
You're at 2 5.
What can I substitute in for what? Because I know 3 is the same as 4. I know 3 and 4 are the exact same thing. So if I take this equation and I substitute blank in for blank. Okay, we're not gonna get it. We're not gonna get it. It's okay. I know 3 is the same as 4. So what happens if I substitute 3 in for 4?
That's what I said.
No, it's not.
Yes, I did.
What'd you say?
Right before you started
What'd you
yelling.
say?
I said 3 and 4.
No, you said 1 and 2.
I know, and then right before you started yelling, I said 3 and 4.
Okay.
I was like,
What does that do for us? Why does that help?
bless you. Bless you.
Oh, that's what you kept saying. You did 2 5s.
yeah.
You did 2 5s. Why does that help?
You owe me a cookie. What do you say?
So this is an equation, right? I'm
Wait.
trying to get 1 and 2 all by themselves. What happens when I move things around a little bit?
What? What did you say?
Josh, what are you guessing? What are you adding to?
I got this.
It's the symmetric.
Substitution property.
Well, yeah, that's the property that we discussed for 6. But how do we get 1 and 2 by themselves?
I have no idea, honestly. Can you explain this whole equation? Because I don't.
Wait, we have to do all this for
Wait, is
every
this gonna
single
be on the
problem?
is it one of these gonna be on the DCA?
No, not on the DCA.
What's on the DCA?
Okay, the reason why I am look at 1 plus 3 equals 2 plus 3. Say instead this had been 2x plus 2 is equal to I don't know, y plus 2. How would I solve for y? Oh my gosh, you subtract 2, and then what happens? Oh my gosh, but what happens to the 2's?
Stays.
Oh, they're out of the equation. What can I do here? Oh my gosh, I can subtract 3, and what happens? They cancel out. Woo! Okay, subtract 3 from both sides, they cancel, and what am I left with? Oh, and how do I know this is true? What did I just do? Subtraction. Postulate, and I'm done.